Determine the slope of the tangent line to the polar curve given by r equals 5 sine 2 theta at theta equals pi divided by 3 radians. To find the slope of the tangent line, we need to determine dy dx and then evaluate dy dx at theta equals pi divided by 3 radians, where dy dx equals dy d theta divided by dx d theta, and dy d theta equals f prime of theta times sine theta plus f of theta times cosine theta, and dx d theta equals f prime of theta times cosine theta minus f of theta times sine theta. F of theta equals r, which in our case is 5 sine 2 theta. Let's begin by determining dy d theta, where again dy d theta equals f prime of theta, which is the derivative of 5 sine 2 theta with respect to theta, which requires a chain rule. The derivative is 5 times cosine 2 theta times the derivative of 2 theta, which is 2, and we have times sine theta, and then plus f of theta, which is 5 sine 2 theta, times cosine theta. Next, we'll determine dx d theta, which is equal to, again, f prime of theta, which is 5 cosine 2 theta times 2 times cosine theta, minus f of theta, which is 5 sine 2 theta times sine theta. Now to begin to simplify, let's factor 5 from the numerator and denominator. Let's write dy dx as 5 times the quantity 2 cosine 2 theta sine theta plus, again, we factored out the 5, so we have sine 2 theta times cosine theta. All this is divided by, again, factoring out 5, we have 5 times the quantity 2 cosine 2 theta times cosine theta minus, again, factoring out the 5, we have minus sine 2 theta sine theta. And notice we can simplify because 5 divided by 5 simplifies to 1. And now we'll evaluate dy dx at theta equals pi divided by 3 to determine the slope of the tangent line. When replacing theta with pi divided by 3, notice 2 theta will be 2 pi divided by 3, and of course theta will be pi divided by 3. So dy dx at theta equals pi divided by 3 is equal to 2 times cosine of 2 pi divided by 3 times sine pi divided by 3 plus sine 2 pi divided by 3 cosine pi divided by 3. All this is divided by 2 times cosine 2 pi divided by 3 cosine pi divided by 3 minus sine 2 pi divided by 3 sine pi divided by 3. Now we need to determine the trig function values for cosine pi divided by 3, sine pi divided by 3, as well as cosine 2 pi divided by 3, and sine 2 pi divided by 3. We can use reference triangles or the unit circle. This time I'll go ahead and use the unit circle. Recall in the unit circle, x equals cosine theta and y equals sine theta, which indicates cosine pi divided by 3 is equal to 1/2. Sine pi divided by 3 equals square root 3 divided by 2. And cosine 2 pi divided by 3 is equal to negative 1/2. And sine 2 pi divided by 3 is equal to square root 3 divided by 2. Let's go back and make these substitutions to determine the value of dy dx. We have 2 times negative 1/2 times square root 3 divided by 2 plus square root 3 divided by 2 times 1/2. This is all divided by 2 times negative 1/2 times positive 1/2 minus square root 3 divided by 2 times square root 3 divided by 2. And now let's begin to simplify. In the numerator we have negative 2 square root 3 divided by 4 plus square root 3 divided by 4. In the denominator, we have negative 2 divided by 4, negative 2/4 minus 3/4, which is equal to negative square root 3 divided by 4, all divided by negative 5/4. Let's continue simplifying on the next slide. To clear the denominators of 4, let's go ahead and multiply the complex fraction by 4/4. Notice this gives us negative square root 3 divided by negative 5, which simplifies to positive square root 3 divided by 5. This is the slope of the tangent line to the polar curve f theta equals pi divided by 3. And let's go ahead and verify this graphically. Here we have the graph of r equals 5 sine 2 theta. This is the point on the polar curve where theta equals pi divided by 3. This black tangent line has a slope equal to square root 3 divided by 5. I hope you found this helpful.